I am going pretty quick this time on test. I'm probably going to have them today. I'll post them on Canvas today, probably. I'm more than halfway through with them already, so these just don't take as long as test 1 to grade. So, okay, and they're looking pretty good too. So, there's always some people that do especially well, or some people that do especially poorly. But as a whole, they're looking pretty good. So, if you feel like you did pretty well on it, you probably did. So, I guess that's it. I was trying to think if we had anything else we really needed to talk about. Can't think of anything else. All right, so we are starting our last little section of material. Material for test 3. So sections that'll be on test 3. In chapter 8, we do a little bit of statistics. And then in chapter 9, we do some financial math. And then that's it. So we'll be finished after that. So I think it's 3 sections in chapter 8, and it's either 3 or 4 sections in chapter 9, and then we'll be finished. So if you're tired of doing calculations, today's a good day for you, because I don't think we have a single calculation to worry about in this section. A fair amount of this section is vocabulary to get you into some of the statistics terminology, and then we have some concepts to look at. No calculations today. We really don't have too many calculations to do in the statistics section at all. Have a little bit, but not too bad. So let's see here. I want to get started. So the idea when we're working in statistics is that we have some question we want answered. And usually our question is dealing with some type of thing we can put a number on. So that might seem kind of limiting, but it's not that limiting, because if you think about it, a lot of questions we want to know the answer to, as far as like social questions and things like that. We want to know like what percentage of people do this, or what percentage of people do that. So those are numerical, right? Those percentages even. So we can use statistics for questions like that as well. So I think we're going to get into some of the details here in a second, so I'll save that. Okay. We have one example here. Okay? Maybe we want to know like what type of car gets the best gas mileage. Okay. So to answer questions like that, okay, anytime we have a numerical based question, okay, we can use statistics to help us with that, and that usually starts by collecting some data. Okay? And then we can make a conclusion from that. So this section is all about different ways that we can collect the data. Okay? We're not getting into the drawing a conclusion part, but we're going to talk about some aspects of collecting the data. Okay? So as we do that, and as we get into this new chapter, okay, we have several vocabulary terms here. Okay? That is one of the most challenging parts of starting to learn statistics. You get used to it eventually. And that's one of the most challenging parts of starting to learn statistics, is just getting used to all the vocabulary, because it's just important to understand what the different terms mean, so we can communicate these ideas with each other. Okay? So that's where we're starting. Okay? It's not too bad. Let's see. We go 1, 2, 3. 6 terms here right away, but they kind of build on each other. Okay? So if we have our big question we want answered, okay, that deals with some group, okay, whether it's a group of people or a group of things. Okay, that group that we want to answer the question about, okay, is what we call a population. Okay. So again, in statistics, a population doesn't necessarily have to be living things, or doesn't necessarily have to be people. We may want to know something about like how many ounces of potato chips are on average or in each bag of potato chips, right? Then our population will be all those bags of potato chips. So it doesn't have to be a living thing in stats. Okay? But the population is the big group that we want to know about. Okay? And the way we try to answer questions about our population is by collecting data. I know you've heard the term before, okay? Just because it's so prevalent, especially right now. It's the last maybe 15, 20 years. Data has come more to the forefront of popular culture. Okay? We hear the terms like big data and data analytics and things like that. So, and all data is some information we're collecting. Okay? That's what we're calling data. So ideally, in an ideal world, if we wanted to know something about a population, we would just collect data from every member of the population. Okay? Like if I wanted to know something about all of you in this room, okay, maybe I would want to know like how many of you, what percentage of you in this room are commuters, right? Just some question like that. Then one way I could answer that question is I could just go around to every person and say, are you a commuter or do you live on campus? Are you a commuter? Are you a commuter? And we could just count those up, okay, and we would get the answer to our question. If we do something like that, that's what we call a census. Okay? And the big idea with a census is that we're collecting data from every member of a population. So last year was the United States Census, the 2020 US Census. And the idea there is that they were going to collect their information they wanted, okay, from every person in the United States. Doesn't always get everybody. Well, it never gets everybody. It doesn't always actually become a census and theoretical census where we get everybody, but that's the goal, okay, is to collect data from every person. Unfortunately, doing a census is not always possible. Okay, so there are several reasons why doing a census would not be possible. Okay? If I'm just collecting data from the people in here, that's not too bad. There's just a few of us, and we just take a few minutes. But when you get on to scales like we want to know something about all the people on the planet, then we've got like 7 or 8 billion people we're trying to collect data from, so that's not really practical, right? So maybe it's just impractical in general, or maybe it would cost too much money, or maybe we don't have enough time before we need our answer to do a census. So ideally, if we want to answer a question about a population, the best way to do that would be a census. But we can't always do a census. Okay? If we are able to do a census, okay, the number that we get, okay, that we're using as our answer to our question, the name we give that is called a parameter. Okay, so that's just some numerical description of a population characteristic. So for my question, I want to know what percentage of you are commuters. Right? We could count up how many commuters we have, divide by how many people we have in the room, change that to a percentage, and that percentage would be my parameter. It would be describing our whole population of everybody in here. Okay. All right. But remember we said we can't always do a census, so what do we do instead? Okay. Well, what we can do if we want to know about a population, but we can't collect data from every member of the population. What we do instead is we take a sample. Okay? And a sample is just a subset of a population. And we have talked about subsets in here, and it's just a smaller piece of the whole. And that's what this section's about, is different ways we can take a sample. Okay? And then what we do is we collect data from every member of the sample. Okay? So it's much easier to collect data from 1,000 people than it is from 7 billion people. That example is kind of extreme, but you can see the benefit of being able to just work with a sample, hopefully. And if we take our data from every person or everything in our sample, collect all that data, the number we get out of that information we call a sample statistic. Okay? So the difference here, it's still a numerical description, but we're describing our sample. On the other one, I may have forgot to underline that part. On the other one, we're describing our population. So one thing that's really important in statistics, even though we may have similar numbers that tell us the same type of information, we have to be very careful about taking note of where our information came from. Okay? Because we have to treat our numbers differently depending on where it came from. So we keep these two terms separate, even though they're a similar idea. It's just a number describing either the population or describing the sample. These are easy to keep together though, because they start with the same letter. Like we have a parameter that describes a population, or we have a statistic that describes a sample. So the S's go together, the P's go together. So little summary slide here. So the big idea is we have some usually big group that we want to know about, and that's usually part of what makes a census impractical. And that's our population. And if we just take a subset of that, we get a sample. We want to know something about a population, so we figure something out about the sample. That's the one we can figure out. Okay? Numerical description of population is a parameter. Numerical description of a sample is a statistic. Okay? When we're starting our study, okay, we don't know the parameter. We can calculate the statistic because we're thinking we collect the data from the sample. Okay, so we can calculate that. The last one's a little subtle, and that's a little deeper than we're going to worry about. Okay? That's some of our basic vocabulary. Okay? Let's look at one example here, and the idea is we want to look at the number and decide if it's telling us about a sample or if it's telling us about the whole population. So if it's telling us about a sample, we'll call it a statistic. If it's telling us about the whole population, we'll call it a parameter. And so let's look at a couple of these. Okay. We've got a little survey report for each one of these. On A, it says a headline about the rising obesity among young people led a school board to survey local high school students. Out of 231 students surveyed, 58% reported eating a high-fat snack at least 4 times a week. So, looking at this one, it says we want to pick out the population, the sample, and then decide if we have a parameter or statistic in here. So, what population are we studying here? What's our big group we're trying to learn about? So the group we're trying to think about here, right, says we've got a headline about the rising obesity among young people. And so our school board, the group that they're trying to learn about, and they're going to give a survey to local high school students. Okay. So sample's easier. Okay. What's our sample? Remember, that's our subset we're taking. Right? I'm gonna be quiet Friday. So our sample, right? We want to know about all local high school students, but we're just gonna deal with just a sample. So a sample here, our sample is the 231 students in our survey. Okay. They're a little weird to get used to them, so that's okay. Yeah. So the big groups, all local high school students, that's our population. Our sample is these 231 students that were in the survey. Okay. So then the last part we want to know, does this number, this 58%, does that tell us about the whole population, or is that just telling us about our sample? What do you think? You got a 50-50 shot. Think it tells us about the population or about the sample? Right. Goodness. Okay. So this one says out of 231 students surveyed, 58% reported eating a high-fat snack. So this 58% is telling us 58% of these people in the sample. So 58% is telling us about our sample, so it's a sample statistic. Yeah, thank you. Sample statistic. Good. Okay. This one is 58%, tells us about the sample, so it's a sample statistic. Because it's just telling us about the ones in the survey. Okay. Now let's look at another one. One more. Oh, goodness. All right, this one says a nonprofit organization interviewed 618 adult shoppers at malls across Louisiana about their views on obesity in youth. The resulting report stated that an estimated 48% of Louisiana adults are in favor of government regulation of high-fat fast food options. Okay. So first thing we want to pick out is our population. So what group of people are we studying here? What? Yeah, adult shoppers. Yeah, and really we can say adult shoppers in Louisiana. Right. Okay. And then what's our sample? I've got the ones that were interviewed. Right. How many of those do we have? 618. Yeah. So the ones that were in the interview, those are our sample. Okay. And then this one's a little tricky the way it's worded. Okay. This one says, or kind of forget the first sentence. Okay. And then just take this sentence for what it says. Okay. It says the resulting report stated that an estimated 48% of Louisiana adults are in favor of government regulation, blah, blah, blah. Okay. So since it's saying 48% of Louisiana adults, is that telling us about the population or the sample? This one, especially the first time you see these are a little tricky. This one is telling us about, it's saying 48% of all Louisiana adults, not just the ones in the interview. Because it doesn't say 48% of those interviewed or something like that. Right? It's telling us about all adults in Louisiana. So this 48% is telling us about the whole population. So we would call it a population, remember? Parameter, right? Population parameter. Because that's telling us about all of these. all Louisiana adults. So a little weird the first time you see them thinking about that stuff, but it's not that bad after you get a little practice in thinking about those ideas. All right, so the rest of the section we're just going to talk about some different techniques we can use to collect a sample. Okay? And the important part, you want to be able to pick out which technique has been used. Okay, so if it gives you a description of the sample, you want to know the name of that sampling technique. Okay? When we collect a sample, we have to be careful. And that's a big part of statistics. We can't just collect any sample. Okay? Because what we want, okay, is we want the sample that we take to look like a little version of the whole population. Right? So like if you're polling people to see if they're Alabama or Auburn fans, okay, you don't want to take your sample of just people that live around Auburn University. Right? Or you don't want to take your sample of just people that live around Tuscaloosa. Right? You want a mix. Right? You want a mix, and we want it to be about the same as the population we're trying to learn about. Because if we are not careful picking our sample, right, if we get too many people that are more likely to be Auburn fans in there or something like that, then that's going to have an effect on our result. Right? We call that bias. Okay, we don't want to be biased toward one group or another there. So that sample, the little sample that looks like our big population, okay, is what we call a representative sample. What we want. Okay. So we want our sample to have the same characteristics as our population. We don't want it to favor one group over another. Okay. So this situation where we favor one group over another, we call that bias. We don't want that. Okay. So that's trickier than it sounds, okay, because it's really easy to be biased toward some particular outcome or some particular value without realizing it. So have to be really intentional and really careful when we're making our samples. Okay, so that's one reason why we have so many different ways that we collect sample data. Okay? Because we're trying to have a representative sample. So the first type of sampling technique, okay, the first way we can collect sample data we're going to talk about is just taking a random sample. Okay. So there we say, every person or every member of our population has an equal chance of being selected, and we're just picking the ones that are in our sample randomly. Okay. So maybe you could give every member of the population, assign them a number, and then do a random number generator to pick out who's in the population, who's in the sample, right? Something like that. So that's a random sample. Okay. The second sampling technique we're going to look at is called a stratified sample. Okay. So with a stratified sample, we take our population and divide it into little subgroups. Okay. And it's kind of like layers. That's where we get the name strata. Right? Strata is like a layer, like on a layer on a cake. Right? And the way we do that is we group them together when they have similar characteristics. So it depends on what the context you're working in, what kind of characteristics you care about. But maybe we would put people in the same age group together, people the same gender or something like that. Okay. each in a strata together. And then what we do is we draw a random sample from each one of the layers. Okay? So the idea there is that if we have stratas for age groups maybe, okay, then the idea is that when we draw a random sample from each age group, we're making sure that we've got some of each one of those in our sample. So trying to remember our goals to get that representative sample. Kind of got the idea on that one? You group similar people together, and similar based on some characteristic, into a bunch of different groups, and then you draw a random sample from each one of the groups. You get some of all the layers. Okay. All right. Let's see if we can think about that. So if we're going back to our fuel mileage, and we're trying to figure out which cars get the gas mileage, get the best gas mileage. Okay. What are some ways we could group different cars together? What do you think? What kind of categories could you think of? Think anything? You know me one of those things. What kind of categories do I have when we go shop for a vehicle? Like, even if you're like just looking online, you know, then you have to have like a category. What kind of vehicle are you looking for? So yeah, SUVs or passenger cars or trucks. Right? That's one way we could do that. So we could put all those in a category, and then they're each in their own category, right? And then we could draw a random sample from each one of those categories. That might work. You could group them together by brand, right? So make. Okay. You could group them together by what else? We could group them together by engine size, things like that. Those would all be possible ways that we could divide them up into strata. Okay? Some of those will be better than others, though, because remember, we have to be conscious of we don't want to be biased, so we'd have to take that into account. Okay. All right, next sampling method, and then unfortunately this one on the surface sounds similar to stratified sampling. Okay, so these stratified sampling and cluster sampling are the two that are the easiest to get mixed up. The other ones are not too bad to keep separate. Okay. So these are the two you have to focus on the most. So cluster sample, okay, we're still dividing our population into groups. Okay. But the idea here, we're not trying to give each group its own characteristic. We're trying to make each group look similar to the whole big picture, the whole population. Okay. And then what happens is that for our sample, we just randomly pick a few of the groups, and then every member of each one of those groups is in the population. So let me try to make a little sketch here to show the difference. Okay. Here. Okay. So let's look at stratified first. Okay. So stratified, what we're going to do is we're going to draw out, or we're going to make some little subgroups, right? We're going to put things into their own little groups. So here I'm going to use different shapes, right? Because I'm going to say each one of these has its own characteristic, right, that we care about. Okay? So you think about like putting all the squares together, all the triangles together, all the circles together, all the parallelograms together. Okay? And then what happens to get our sample? Okay, so we end up with our sample over here. What happens to get our sample is we're going to take some out of the squares, some out of the triangles, some out of the circles, some out of the parallelograms, right? Randomly, but we randomly get some out of each one of the strata, and then that makes up our sample. Okay. With cluster sampling, a little bit different, because we start off with our population, and then with cluster sampling, or the way we divide it up into groups, is we want all of our groups, I should do all these circles, we want all of our groups to look like little versions of the population. And then what happens in our sample is that we randomly pick some of the clusters on some of those groups, and then those whole clusters are in our sample. So to get our sample here, like we would pick this cluster and this cluster, and they would go into our sample. So a little different, easy to get them confused. Okay, easy to get them confused. Those are the hardest two. Okay, hardest two to remember. So that's cluster sampling. Let's see here. So a little bit of a weird question here because it doesn't match up exactly, but it says, do you think it would give us a representative sample if we allowed our clusters to be price ranges? So this is saying we're going to make our groups be the different price ranges and then pick the different clusters. And what they're doing on this is they're mixing the idea of stratified and cluster sampling. Okay? So this would be a bad idea. Okay? Because remember, with cluster sampling, okay, we pick each cluster, right, and that whole cluster is going to be in our sample. So if we tried to do cluster sampling, but we split our categories up into price ranges, and that means some of the price ranges would not be in our sample. So that would not be representative. So don't stress over that one too much. All right. Next type of sampling here. Okay. Called systematic sampling. Okay. And it's just what it sounds like. You just come up with some formula or some system you're going to use to pick which members of the population are in the sample. So I could say I'm going to go down each row, and every third person I'm going to put in my sample. Something like that. Or every fifth person that walks through the door, they're going to be in my sample. I just have some system. Okay. And then one more. Okay, we're skipping this slide. And one more called convenience sample. Okay. This one gets used more than it should. Okay. You can guess by the name, it's convenient. And the way it's convenient is it's convenient for the researcher, so it's convenient for whoever's collecting the data. Okay. So the idea of convenience sampling is if I wanted to pick a sample of the people in this room, I could say it's going to be you, and you, right? because it's convenient because you're close to me. Or if I wanted to say, I'm trying to study all the students at JSU, the way I could collect a sample is I could pick all the students in my class because it's convenient, because you're all the ones I have access to easily. Okay, so that's all convenient sampling is. Okay. All right, so let's look at a few, okay, and see if we can pick out which type of sampling has happened, because that's the other type of problem in this section. So, okay. So A, I want to pick out what type of sampling technique. A says to conduct a survey on collegiate social life. You knock on every 5th dorm room door on campus. Good, yeah, that one's going to be systematic, right? We just have a system. So every 5 doors we're going to knock and then ask those people our questions, right? So this one would be systematic. Okay. All right. B says student ID numbers are randomly selected from computer printout for free tickets to the championship game. Yep, yeah, so that one gives us a good hint. Yeah, it says randomly selected, so this one is a random sample. Okay. Questions on either one of those two? Those two are not too bad. Systematic's usually pretty easy to pick out. Random has to say it's random, so that helps. Okay. C says 4th grade reading levels across the county were analyzed by the school board by randomly selecting 25 4th graders from each school in the county district. So this is either going to be cluster or stratified. So that's the tricky ones we have to think about. So here, okay, we're looking at 4th graders at each school in the county district, and we're going to randomly select some from every school. So you got a 50-50 shot. It's either cluster or systematic. Which one do you think on that one? If we're randomly picking some from each little group, yeah, that one's stratified. Good. So if we take a random sample from each little group, that's stratified. Okay. Did I spell that right? Okay. And then D says, in order to determine what ice cream flavors would sell best, a grocery store polls shoppers that are in the frozen food section. Thing on that one. Yeah, it's convenience. Yeah, we want to figure out what flavor of ice cream people like. We stand by the ice cream and ask people. So that was just convenience. One of those days. Convenience. And then what about the last one? You should have a good guess because it's the only one I haven't used. It says to determine the average number of cars per household, each household in 4 of the 20 local counties were sent a survey. So here, our data is grouped together by county, and we're picking 4 of the 20 counties, and everybody in each of those 4 counties is in our sample. So that one's a cluster. Yeah. So if we get some of all the groups, right, randomly get some out of each group, that's stratified. Okay. If we just randomly pick some groups and use that whole group, that's cluster. Cluster. And this last one is cluster. Okay. Those are stratified and cluster really the only two that are too challenging. Okay. Some of the convenience ones are weird, but just think if we're just picking it because it's easy, that's convenience. Questions on those? Can't think of anything? All right, have a good weekend. If you didn't get on the sign-in sheet, make sure you get on there before you leave. That's it for today.